I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the surface modification using the various techniques in which the surface composition is modified in order to achieve the required changes in the surface properties, so that the wear resistance and the corrosion resistance of the surface layers can be improved for a prolonged performance of the component. And under this category we are talking about the vacuum based surface modification techniques, and wherein we have talked about the ion implantation and ion plating. Now you will be talking about the two other techniques. These are like sputtering and ion beam assisted deposition. So these are the two different techniques we will be talking about. First of all, sputtering. So what is the process of sputtering? In case of the sputtering, like this is basically depositing a material on the substrate using atoms and ions of required material. So basically there is a substrate on which the material is to be deposited. So the material which is to be deposited is termed as the target. This target is subjected to the application of the high velocity, high energy ions. So impact of these high energy ions with the substrate displaces the or removes the atoms from target, as well as about 1% of the atoms will be coming in form of the ions and electrons. So ions which are coming are positively charged and electrons are the negatively charged. So at the same time the atoms will also be coming out from the target surface. So some of these atoms and the ions which are coming out from the target, they move out from the target surface at a very high speed, just like the ballistic movement is achieved in these atoms. And so these atoms and the ions will be moving in the different directions, and when they move in the different directions they will be depositing here and there. Some of these high energy ions and atoms will be moving and depositing or impacting at the surface of the substrate as well, and there they get deposited. So basically we are getting the high energy atoms and ions from the target material, which is basically material to be coated. So the target or the coating material which is to be deposited on the substrate is subjected to the high energy ion beams, so that the material from the target or the coating material is removed in form of the atoms and the ions, and some of these are of very high energy, come out like a ballistic movement, and they will be impacting with the various surfaces which are all around, including the substrate surface, and there they get deposited. So once they get deposited, they will be forming a kind of the films. So this is the general principle of the sputtering. So basically we can use the argon ion beam or the nitrogen ion beams for producing the high energy atoms and the ions from the target material, and for producing these high energy ions we may use magnetrons or the diodes, which will be directed onto the surface of the target material, and then whatever the ions and the high energy atoms are achieved, they are further accelerated towards the substrate using suitable bias created between the target and the screen. So basically in between the substrate and the target we have one bias which is also called screen. We will be putting in the height difference between the screen and the target material, so that the high energy ions and the atoms can be further accelerated towards the surface of the substrate. So these are the important features related with this process. So now we will see like this, the ions of the argon or the nitrogen are directed at a high with the high energy onto the substrate, onto the target, which is basically the coating material which is to be applied. So with these impact and will be producing some of the ions of this target material, and the atoms are also removed. So atoms as well as the ions are produced, and then these are accelerated towards the substrate using suitable bias, so that they can be deposited in very controlled way over the substrate. The kind of arrangement which is used here is like this, like there is a one chamber, and on this is our target or the material which is to be deposited, and here we have one opening for vacuum, and then the other side we have the substrate. Substrate or the workpiece material, and between these two we have one screen which is used to create the bias between the target and the screen. So the ion beam is directed onto the target material. So ions and atoms are released from the surface, and these are accelerated towards the substrate by putting in the sufficient bias between the target and the substrate. So this is our screen. This chamber is filled in with the ion forming gas like the argon, and this is the substrate. So these ions and the atoms accelerated towards the substrate will be impacting with the substrate material, and so they will get deposited. So all these will be moving towards the substrate, ions plus the atoms. Since there is not much control over the direction in which these ions and atoms will be moving, so there will be very high tendency that whatever the atoms and ions are being released, they will get deposited in the inner wall of the chamber as well, and that is why the deposition efficiency of this process is very less, we may be losing the target material significantly through this sputtering process, but the kind of material or the amount of material which is deposited on the substrate is very less, because whatever material is removed in form of the atoms and ions, that will be deposited in the internal surfaces as well as at the surface of the substrate. So, these are the different constituents as far as the sputtering process is concerned. And for ionization or for having the high energy ions, we may use diode or the magnetron, and high energy ions can be generated using the argon or the nitrogen gas mixture, which will be filled in the chamber. So, these are the some of the features as far as the sputtering process is concerned. In this case, the extent of the bias of like 5000 volt or 10,000 volt will be determining the way by which the ions and atoms are accelerated towards the substrate, and therefore it will be affecting the deposition rate on the substrate material as well as the quality of the deposition. In general, increase in the bias will be increasing the deposition rate as well as the bonding of the material which is being deposited with the substrate. Because this will be affecting the energy associated with the atoms and ions being moved towards the substrate, and which in turn increase in the acceleration or increase in the energy with which they will be impacting with the substrate, will be increasing the bond strength of the deposition with the substrate, or the coatings or the film which is being deposited, that will be increasing with the increase of bias or with the increase of the kinetic energy. So, increase in bias will also be increasing the kinetic energy, which may also improve the mechanical properties of the modified surfaces when the higher bias is used, which will be leading to the increased acceleration of the atoms and ions being deposited on the surface of the substrate. So, this is the general principle of the sputtering process. We use the high energy ions which are directed onto the target material, and this target material will be producing the atoms as well as ions. These will be coming out at a higher speed from the target material, and then these will be moving here and there. Some of these will be moving and impacting with the internal surfaces of the chamber, as well as some of these atoms and ions will be depositing with the substrate. In order to have very controlled deposition at higher controlled deposition over the substrate, using these ions and the atoms which are coming out from the target material, bias is used of the sufficient strength so that these can be accelerated towards the substrate in order to have the good bond strength as well as sufficient deposition rate. Now, we will be talking about the another very useful surface modification technique by changing the chemical composition, that is the ion beam assisted deposition. So, as we have seen in case of the vapor deposition and sputtering, in both these cases or ion plating. In these three processes, all those which are performed under the vacuum conditions, the kind of the material which is deposited on the surface of the substrate, it does not form the bond of the very good strength with the substrate. In vapor deposition, the metal vapors rising with the low energy and impacting with the substrate and getting deposited. In case of a sputtering, although energy is quite good, but still the bond strength is not that good. While in case of the ion platings, the metal vapors are ionized and then they are directed on towards the surface using the suitable potential difference between the substrate and the target material, so that these can be accelerated, but still the bond strength is not good. The primary reason for that, we have very sharp, the interface is very sharp, like this is the substrate and this is the coating material which is deposited either using the vapor deposition, sputtering or ion plating. So because of the sharp interface, we find lot of problems, especially when there is metallurgical incompatibility or there is a difference with regard to the thermal expansion coefficient. So if the alpha is too different or the metallurgical incompatibility exists, then the sharp interface leads to the increased tendency of the spalling or delamination and the poor that happens primarily due to the poor bonding of the coating or the film which is deposited with the substrate. So this issue is primarily addressed of all these three processes if the ion beam is used in combination with the vapor deposition or sputtering or ion plating. So in that case, what basically we do is that the target material which is being deposited, like say this is the target material, and target material either we are applying the heat so that it is evaporated and gets deposited on the surface of the substrate at a very low energy, or we are applying the ion beam on the substrate so that the high energy ions and the atoms are achieved from the target material, and they also get deposited on the substrate in case of the sputtering process. So in case of the metal vapors, vapor deposition, metal vapors are used. In case of the ion deposition, then the metal vapors are ionized and then they get deposited. In case of sputtering, the ions and the atoms which are obtained through the sputtering process get deposited on the surface of the substrate. In all these cases, we find very poor bonding. So in order to increase the bonding, what we do, once during the process of the deposition, either by metal vapor deposition or the sputtering or the ion plating, we use a ion beam, individual source of the ion beam, and that is directed towards the surface of the substrate on which the material is being deposited through the various approaches, either through the metal vapors or the sputtered ions and the atoms or the metal ions which are obtained through the ionization of the metal vapors, and these the material deposited is subjected to the ion beam treatment, wherein the ion beam impacting with very high energy onto this material deposited onto the substrate. So this will be leading to the proper mixing of the material being deposited by the various other techniques. So when these ion beams are applied over the coating that has been deposited over the substrate, this is substrate, and this is the coating or the film which has been deposited. When it is subjected to the ion beam, this leads to the very good intermixing of the coating and substrate material, and once this intermixing is facilitated, we get very good the bonding of the surface material with the substrate and very good gradient between the surface and the subsurface properties. Obviously, the concentration of the modified surface at the surface, the concentration of the deposited material will be more, and it will be gradually decreasing towards the surface. So, we get very good bonding, as well as we get very good the gradient with respect to the composition and the compounds which are being formed, and this in turn will be leading to the very good gradient as well as gradient in respect of the mechanical properties as well. So, what we are getting, intermixing is facilitated extremely good metallurgical bonding and very good gradient with regard to the chemical composition and the mechanical properties. So, whether we are using the vapor deposition or we are using the sputtering or ion plating, in all these cases, if the ion beam is used and applied onto the surface which is being modified through these approaches, then it will help to enhance the performance and the properties of the surfaces in much better way. So, and this is achieved primarily due to the extremely good intermixing of the coating material with the substrate. In addition to this, there are many other benefits which are achieved when the ion beam assisted deposition is used. So, what we have basically ion beam assisted deposition, there are two key benefits. We know that whenever ion beam is directed onto the surface, all surface impurities, fine thin oxides are removed. So, it is a self cleaning process. So, the cleaning, external cleaning or prior to the modification is not that crucial. So, the one advantage is that self cleaning process, and it ensures very good intermixing of the material which is being applied with the substrate, and this in turn helps to increase the very good bonding of the coating material with the substrate. So, coating substrate bond is extremely good, and the process is cleaning achieved in this process is very good, and this offers the very good gradient in terms of the composition, in terms of the properties, and this gradient helps in reducing all undesirable effects related to the cracking or undesirable combination of the mechanical properties. And because of the very good intermixing, we get the reduced metallurgical incompatibility issues. So, metallurgical incompatibility issue is reduced primarily because there is no sharp gradient, no sharp interface, while it has proper intermixing and the very good gradient with respect to the composition and the properties exist. For example, if we have deposited a particular element at the surface like chromium over the surface of the steel, and then ion beam is applied using the nitrogen, then we will be getting the extremely good mixing of the iron nitride Fe3N4, and the concentration will obviously be gradual, less at the subsurface and more at the surface region. So, this continuous gradient will be leading to the extremely good improvement in terms of the hardness, in terms of the wear resistance. And when the gradient is good, mixing is good, despite of forming Fe3N4, the cracking tendency and the brittleness tendency is reduced. So, cracking tendency and the brittleness tendency is reduced when ion beam assisted deposition is used. So, the general principle of this process is what? Substrate and the suitable source of the target material which is to be deposited, and this may be in case of the sputtering, in case of the ion plating, or in case of the vapor deposition. These the target material will be providing the either atoms, ions, vapors, which will get deposited, which will be moved towards the substrate. On the substrate they will get deposited using a suitable independent source of the ion beam. This beam is directed onto the surface which is being modified. So, this ensures extremely good mixing of the material deposited, and this mixing improves the bond strength, results in a very good gradient, reduces the metallurgical issues and other cracking tendencies associated with this process. So, with regard to the ion beam assisted deposition, it offers the number of advantages over the conventional sputtering, ion beam plating and the vapor deposition, especially with regard to the improved bond strength and reduced metallurgical incompatibility. Now, I will summarize this presentation. In this presentation, basically I have talked about the two techniques. One was the ion beam assisted deposition and another was the sputtering. So, in case of the sputtering, deposition is achieved through the atoms and the ions, while in case of the ion beam assisted deposition, we can use the atoms, ions or the metal vapors using various techniques like sputtering, ion plating or the metal or the vapor deposition. But in all these cases we need to use the ion beam so that the surface can be cleaned and good intermixing can be realized for improved properties of the surfaces. Thank you for your attention.